Well, good morning. How are you all today? I got a couple of little fellows here on my lesson plan. I kind of think they're fun. Remember when you used to play with stuff like that? Oh, good times, good times. So they'll just be hanging around here. I'll just set them right over here. Okay, there we go. Okay, I tell you what we're going to do today. Let me autofocus this. Okay, there we go. Okay, we're going to simplify radicals with variables under the radical. Okay, this is actually the last lesson that we're going to do this year. This is the last thing I'm going to teach you. So this is pretty cool stuff. Let me show you how this works. Okay, first of all, before we even start anything, remember that if I have x squared and I take the square root of x squared, I just get x. Okay, because we know that x times x, we add the exponents. X times x is x squared. Okay, now keep that in mind, and let's look over here. Okay, number one is the square root of 9x. So what I'm going to do is split up the number from the variable. So I'm going to think of this as the square root of 9 and the square root of x. Okay, the square root of 9 is a perfect square. That's 3. The square root of x I can't do anything with because that's only x to the first. So that's just that's just your final answer is 3 root x. Okay, now let's look here. Number 2. I have the square root of 7x. Well, if I were to think ahead, and if I were to square root the 7, that's not going to get me anywhere because 7 is not a perfect square, nor does it have any perfect square factors. The square root of x cannot be simplified, so this is in simplified form. The square root of 7x cannot be simplified further. Okay, now let's look at this one. Number 3, the square root of x squared. Well, we talked about that up here. The square root of x squared is just x. Okay, now let's think this one through. Number 4 is the square root of x to the 10th. So we're saying, okay, what times what would give me x to the 10th? Just like the square root of 9. I'm thinking what times what would give me 9? Well, 3 times 3. So the square root of 9 is 3. Here, what times what would give me x to the 10th? Well, remember that when you have exponents and you're multiplying, it's not a power to a power, okay? When you have two exponential expressions with the same base, x and x, you add the exponents. So we got 2. So down here, if I have the square root of x to the 10th, then I'm thinking x to the what times x to the what gives me x to the 10th. Well, since I have to add exponents to get 10, and these two have to be the same thing because it's like squared, then we know it's x to the 5th times x to the 5th, because 5 plus 5 would give me 10. So the square root of x to the 10th is actually x to the 5th. Because, let's think about this another way, if I have x to the 5th and I square it, now this is a power to a power, so you multiply. 5 times 2 would give you x to the 10th. Okay, now the easy way to think of this is you just take the exponent and divide it in half, so that when you add it, you get the exponent that you're looking for. Okay, now notice I did not look for the square root of 10 at all. I'm not doing the square root of 10. I'm doing the square root of x to the 10th, which is a completely different expression. Okay, let's look here at number 5. Here we have an x on the outside. Here I have an x to the 8th. Okay, x to the 8th is a perfect square because this is a positive exponent. No, I'm sorry, not because it's positive, because it's an even exponent. This is a perfect square because I know that x to the 4th times x to the 4th would give me x to the 8th. So I have x times the square root of x to the 8th is x to the 4th. So now my final answer, I'm going to add those two, so I get x to the 5th, and that is my final answer. Okay, purely coincidental that these two ended up being the same answer. I did not plan for that to happen. Okay, next one. X to the third times the square root of x to the fourth. Okay, again, x to the third is on the outside of the radical, so I'll leave it as x to the third. Now, the square root of x to the fourth is x squared, because I know that x squared times x squared, 2 plus 2 is 4. That would give me x to the fourth. So the square root of x to the fourth, this right here, is x squared. Now I'm going to add exponents. Oh my golly, I ended up with x to the fifth again. I really should have cycled through these problems first. I did not plan for 3 in a row to end up being x to the fifth. Okay, I'm going to go with it. I'm not going to retake the lesson. We'll just go with it. Okay, next one. Number 7, the square root of 5x squared. Okay, so I'm going to split this up like I did back here because I had a number and a variable. So this is the square root of 5 and the square root of x squared. Okay, the square root of 5 cannot be simplified. The square root of x squared, well, that is a perfect square. The square root of x squared is just x. Okay, we don't write our answer like that. We write what's not under the radical first, x, and then we write the radical. So the answer for this would be x root 5. Okay, a little similar to those, but not exactly. All right, let's go down to number 8. Here I've got the square root of 16x to the 7th. I'm going to split up the number, the square root of 16, and then I have the square root of x to the 7th. Interesting. Okay, the square root of 16 is 4. X to the 7th is not a perfect square because it's not even. Like back here, we need an even exponent to be a perfect square. But what I can do is split up x to the 7th like this. X to the 6th times x to the 1st. What I did is I have x to the 7th, not an even number, so I'm going to go down to the next even integer, which is 6. So I'll have x to the 6th times x to the 1st. Now, we still have the 4. The square root of x to the 6th, now that's even, so that's going to be x to the 3rd, and then I'm left with root x. That's our final simplified answer right there. So you're going to write this as 4x to the 3rd root x, and that will be your final answer. Okay, look at how far you've come. You've come from this all the way down to here. Now you're learning how to simplify radicals with variables under the radical. Okay, let's look at this one. We have x. Now, keep in mind, we're not doing the square root of 25. We're doing the square root of x to the 25th. 25 is not even. So I'm going to go to the next even integer down, which would be x to the 24th, and then I need an x to the 1st, so that 24 plus 1 would give me my original x to the 25th. Okay, now I have x times. Okay, half of 24 is 12, so that's going to be x to the 12th. Keep in mind, when I did x to the 24th, the square root of that, I said x to the 12th. Well, that's because x to the 12th times x to the 12th, you would add 12 plus 12 and get x to the 24th. So the square root of x to the 24th is x to the 12th. And then I still have root x. Okay, these two again are outside of the radical. So we're going to multiply those. And when I do that, I add the exponents. So I have x to the 1st times x to the 12th. So x to the 13th, and then root x. And that will be my final answer. Okay, now, number 10, this is the last one I want to do, the square root of 4x to the 12th. Well, I'm going to split that up as root 4 and root x to the 12th. Okay, the square root of 4 is a perfect square, that's 2. X to the 12th is actually a perfect square because that's an even integer. So half of 12 is 6. So that becomes the square root of x to the 12th is x to the 6th. And I don't have anything left under the radical. So I ended up with just 2x to the 6th. From here to here, it's just 2x to the 6th. And that will happen sometimes. You might end up with a perfect square like this one, this one. This one was a perfect square. This one was a perfect square. But anyway, that can happen. So review these if you need to. That takes care of it. Here's my guys. They were watching the whole time. I think that, did you guys see enough problems to understand it? They're saying yes. Okay. So that takes care of it. We'll just end it right here and try some Delta Math problems. And you guys are doing fantastic. Okay. Bye-bye.